Morgan here for Onefinity, and today I'm going to show you how I made this unnecessarily fancy Scrabble board. So I made this as a gift for my parents, who are both fairly recently retired, and they love Scrabble. So I thought it would be nice to make them a board that they could keep out in the house, almost like a furniture piece. Now, I don't really consider woodworking projects difficult. I would say that woodworking projects just have varying degrees of tediousness, and buddy, this one is tedious. I say that just because there's a lot of steps, but if you're willing to invest the time, grab a snack, buckle up, and get in the chopper. Let's do this. I designed this thing so that the space for the tiles would fit the regulation Scrabble tiles, but I made some changes to everything around it. I wanted to leave room around the outside to add some personalization, a score key, the Scrabble logo, and instead of separate pieces to hold the Scrabble tiles, I figured I could just route some slots right into the game board. So I found a great free vector file online of each part of the game, separated out. I found the one showing the spaces for the tiles to go into. I scaled that up just slightly because I'd rather those cavities be a bit oversized than undersized. Then I added a box around it to give me the overall shape of the game board and show me the space available to add other things. To continue planning this thing out, I had to scour through my scrap pile to see what types of wood I had available because for the different color spaces on a Scrabble board, indicating 4 different scoring variations, I wanted to create those contrasting colors with wood inlays. Sure, I could have made it a lot easier on myself and just done some simple epoxy inlays, but just not my style. In woodworking and in life in general, I just like to make things difficult on myself. As difficult as possible. The 4 wood species I chose to rescue from the scrap pile were walnut, rosewood, osage, and purple heart. We'll get more into the inlay process later, but for now, we're just going to start with the base, the foundation if you will, and if you won't, I will. It's nothing fancy, just some solid hard maple, flattened, planed down to uniform thickness, and glued up to give me slightly over 20 inches by 20 inches. The whole board will be cut out of this at the end, so I need to leave enough space around the outside. The various wood species will be inlaid into the main board at a depth of 1/4 inch, so I wanted it to be at least 1/2 inch thick. Once the inlays are in and flattened down flush with the top surface, I need to glue on a separate piece of maple, much thinner, to create the recess for the tiles to sit in, while still showing the wood inlays underneath. Then once that part was glued on, we'll do a few more wood inlays, then add a logo and personalization as a 2-part epoxy inlay. Okay, now that we have our order of operations figured out, or at least I think we do, let's get all these vectors into Vcarve and start toolpathing this bad boy. We'll set the dimensions to 21 by 21 and the thickness to 5/8 of an inch. First thing I'm going to do is flatten the main part. I'm going to be doing a bunch of inlays across the whole area here, and any variation in thickness would mess up my inlays. So it's imperative that the top surface of the material is dead on parallel with the Z-axis. So I'll whip up a little square here, just larger than the workpiece, so the bit doesn't leave those annoying little nubs in the corners. The next toolpath we're going to do will be for the pattern of wood inlays in the base of the board. To find out where those need to go, I'll go ahead and pull in the vector for the tile cavities, which we'll work on in a bit. But for now, I just need to get the placement right so I can cut out these inlays. So we'll bring this in and center it to the model. Now, I don't want to cut my inlays the exact size of the tile cavities, and here's why. I made my workpiece oversized so that when I glue the top part down to the base, if I'm a little bit out of alignment, it won't matter because I'm cutting the whole thing out of the middle. But if the parts are misaligned and the inlays are the same size as the cavities, that misalignment would be noticeable. So I'll make these inlays just slightly larger than the tile spaces to cover all the edges of the inlays. We do that by selecting all these squares here, go to the offset tool, and we're going to offset to the outside of these vectors by 0.03 inches. I'll just go ahead and do all of them now, then only select the ones I need when I start toolpathing it. Alright, so if you haven't messed around with it yet, Vcarve 12 totally revamped the way that they do inlays, and they're so easy. It's crazy easy. So what I need to do here is reference a diagram of the game board with color so I actually know which spaces to cut out, because I can never remember. And no need to separate them out by color individually because these inlays will all be the same size and shape. Now here's where it gets a little tricky. The way that Vcarve has the inlay toolpath set up, it wants to create a mirror image of the vector and create a separate sheet for the inlay material laid out the exact same way. Because I'm using 4 different types of wood spread out across the entire board, I can't really have it set up that way. So what I did was, in the new sheet where all the inlay plugs ended up, I just created simple rectangular vectors the same size as the various pieces of wood I'd be using to cut the plugs out of. Then I just counted up how many plugs of each wood species I would need, selected that number of squares, and dragged them into their respective rectangles. And the parameters that were assigned to these vectors when they were created will stay the same. Select all the squares and the boundary and recalculate. And this part is optional, but I added a clearance tool just to save some time. I use an 1/8 inch spiral bit. When you go to cut these out, it'll use the same work origin as everything else. I needed 8 rosewood plugs, 12 purple heart plugs, 16 walnut plugs, and 24 Osage plugs. Here in the Vcarve inlay panel, you'll see pocket depth, glue gap, and surface gap. I set the pocket depth to 0.25 inches, the glue gap to 0.01 inches, and the space above the material, the surface gap, to 0.03 inches. And I don't know if there's any science behind this, but I like leaving a little bit more space above the material because the inlays and plugs are tapered, and I feel like leaving more space there prevents the plugs from bottoming out and not fitting right with the top shoulders of the pocket. I don't know, could all be in my head, but it's worked for me. That also leaves some wiggle room to remove the waste material from the plugs. Rather than flattening the whole surface bit by bit, I can select just those vectors where my inlay plugs are and cut them down to where they're just above the surface, so flattening it later on will go a lot faster by not having to take so many dang passes. I'll cut those down to just almost the surface, then run a flattening toolpath over the whole thing. And we can just use the same flattening toolpath that we already had when we started. After our inlays are in there and everything's flattened, we'll need the top piece to glue up over top of the inlays. So let's do that. So we'll select all the vectors where the tiles will go, and remember, we offset all those to make the underlying inlays a little bit bigger. Just make sure you select the smaller ones, the original size. Now click on Profile Toolpath, and we'll be cutting inside the vectors. We'll use an 1/8 inch spiral bit for this, spinning round and round at 20,000 RPMs at 150 inches per minute. Let's set our depth to 0.125 inches, and we'll do that in 2 passes. Now, when I did this, I made a slight error. I left the workpiece thicker than it needed to be, thinking I would just flatten it down to the correct thickness after I cut out all these squares. And in doing so, I did not a ton, but slightly more than a little bit of damage to this part. I did that so I could just glue up the panel with reasonably thick boards. You ever tried to glue up 5 separate 1/8 inch thick boards? It's basically not, just don't do it. The space between these open squares are so small, making the material that remains very brittle. So I had to do some repairs. It wasn't the end of the world, but it was annoying and avoidable. So just get that thing down to final thickness first, then cut out the squares. Okay, once you have that top piece done with all the cavities for the tiles cut out, that'll get glued onto the main piece with the inlays already in, then we can start machining the top piece. On that will be some inlays. 4 of them will be wood, corresponding with the different point values we inlaid on the main piece, and the rest will be epoxy, some single color, some 2 color. And we'll also cut some slots for the Scrabble tiles to sit in. So let's start with the 4 wood inlays. Those will do pretty much the same way that we did the first set of inlays. These are a little bit bigger and I only need 1 of each. So I'll select these 4 squares here and create another Vcarve inlay toolpath. We'll use the same settings, same bit, all that stuff, and again it'll ask me where in the project I'd like the plugs generated. All I have to do is create a rectangular vector the same size of the piece I'm using and move the plug vectors that were generated into that rectangle. Regardless of where I move those vectors, they'll retain the toolpathing parameters that were assigned to them when they were generated. Alright, the hardest part is over, and it wasn't even that bad. Now let's move on to the epoxy inlays. On 2 opposite sides of the board, we have some inlays I put in there to personalize it. My parents' names spelled out in Scrabble tiles. I'll include the DXF and SVG vectors for all those tiles in the cut files that I put up on the forum so you can change those letters to whatever you want. Anyway, all the inlays on the top piece will be cut the same way. Only 4 of them will have wood plugs and the rest we're going to pour epoxy into. For the name tiles, that's going to be a 2-part epoxy inlay. When we cut those out, we'll select the outer squares only, not the letters and numbers. That'll leave completely open pockets to fill with epoxy. Okay, we'll select all those squares and the Scrabble logo. The software will generate plugs because it thinks that we're putting wood into those pockets, but you can just ignore those. Now that just leaves the slots for the tiles to sit in. Now I'll be honest, I messed that part up too. These slots were supposed to be just wide enough so that the tiles could sit in them, leaning back at a slight angle. And I cut those slots too wide because I toolpathed this before the tiles I ordered came in, and the actual tiles aren't as thick as I thought they were, so they just kind of fell down. And that's why you see the black border around all those slots. I figured the best way to fix it was to make it look intentional. And I did that by clearing out an oversized pocket, filling it with epoxy, then cutting the slots into that. But again, that was a fix to a mistake that I made, so that's not part of this video or the cut files that will be provided. The slots are just simple lines, spaced apart just a tiny bit to get the correct width. I cut them out as a profile toolpath, cutting on the vectors using an 1/8 inch spiral bit. The last toolpath will be the profile toolpath, cutting both parts to its final dimension. It's just a 20 by 20 square, cutting outside the vector with a 1/4 inch spiral bit. And that takes care of all the toolpathing. Whew, that was a lot. All right, let's save these G-code files and get to machining. I'll be cutting all this on my Elite Woodworker, so I'm just going to make sure that that post processor is selected. Now in Vcarve, if you have multiple sheets, when you're saving G-code files, it'll only show you the toolpaths created in the sheet that's currently visible. You'll see this little drop-down menu here to switch between the sheets within the project. Just make sure you go through all those and save every toolpath you created in every sheet. Drop them onto a thumb drive and bring it over to the machine. As with any project, you start by securing your material to the wasteboard, probing for X, Y, and Z to get your work origin and material thickness all set up. And we'll start by working with the main piece of the game board. The first thing you're going to want to do is run a flattening toolpath to ensure that the top surface of the workpiece is dead on parallel with the Z-axis. Very important when you're doing inlays. I use an obnoxiously big flattening bit that I got from Bits and Bits. It's 2.5 inches in diameter. After it's flattened, you can load the first toolpath, which includes all the inlay pockets. Put a 60-degree V-bit in your collet, probe for Z, and run it. Once all those inlay cavities are cut out, you'll need to start cutting plugs out of your other workpieces. Now my work origin didn't change because I use stops to maintain a constant X and Y 0. But if you didn't do that, just probe for X, Y, and Z again, then load your first inlay plug toolpath, run it, and repeat for all remaining plugs. See? I told you guys this was tedious. After you've machined all of your inlay plugs, you can start cutting the top piece. Secure the material to the wasteboard, probe for X, Y, and Z again, and run the same flattening toolpath you used for the main piece. Once it's flattened, open the profile toolpath that cuts out all the squares. This will take a little while to cut out, not crazy long, but good enough amount of time to take your plugs over to the bandsaw and separate them out into individual parts. Now you don't need a bandsaw to do this, but it's the method that I like best. You could create a boundary around your plugs and cut them out on the machine, but bandsaw is just faster. Once they're all separated, brush on some glue and pound those plugs into the main piece, then wait for it to dry. Once it's dry, you can put the piece back onto the machine with the plugs sticking up and run the toolpath you created to cut the pockets just over the plugs. That toolpath was made to use a 1/4 inch spiral bit. After that toolpath, switch to a flattening bit and flatten the whole thing down. Now that the squares are all off the top piece and it's off the machine, you can glue it right down to the main piece, making sure all the edges of the inlays of the main piece are covered by the top piece. Once that dries, we'll put the whole assembly back on the machine and cut the inlays and tile slots out of the top. Once you've done that, load your first toolpath for the top. Here's where we're going to cut out the inlay pockets for the point value guide, the name tiles, and the Scrabble logo. I grouped these together because they're all cut with the same bit. So for this one, we're using a 60-degree V-bit. Make sure you have that bit in the collet before probing for Z. Okay, now you've got all the inlays on your top piece cut out. Let's go ahead and glue in the wood plugs, and while that's drying, pour the white epoxy for the name tiles. And depending on what kind of epoxy you're using, this can take a while. There's so many videos out there about how to mix and pour epoxy, I don't really feel like I have to cover that here. Just pour some epoxy, you know. After the epoxy is cured, the wood glue will have long since dried. Now you can put the whole thing back on the machine using the same work origin that you set up at the beginning. Again, we're using a 60-degree V-bit, probe for Z again, and run the black epoxy toolpath. I will carve out the pockets for anywhere with black epoxy. After that, I just poured the black epoxy in those cavities we just cut. That'll be the letters and numbers on the name tiles, the point value indicators on the wood inlays, and the Scrabble logo. Again, that's going to take some time, so I don't know, go for a picnic or something. Or do some chores around the house for once. Jeez. And after the epoxy cures, we're in the home stretch, just 2 more toolpaths to run. Put an 1/8 inch spiral bit into the collet, probe for Z, and run the tile slots toolpath. That one will go pretty quick. Now to remove the excess black epoxy and just generally kind of clean up the surface, we'll do one last flattening toolpath. You know the drill. Put in a flattening bit, probe for Z, run the flattening toolpath. Now, finally, I'm going to add a nice thick mitered rosewood edge banding around the outside. That covers up the glue line where the top piece meets the bottom piece, and I think it's just a nice way to frame it out and give it a nice finished look. And those edge banding parts I cut on the table saw and actually didn't film those parts. But just to give you a quick rundown, cut 4 pieces slightly longer than the length of each side of the board and cut a 45-degree bevel on one side of each of them. Get one corner nice and tight, then mark the short edge of the other. Then just carefully cut the miters on all the other parts, and those should fit together nicely around the whole board. Then it's just the old glue, clamp, sand, and finish game we all know and love. Now for finishing, I normally just say use your finish of choice, but in this case, I'm going to make a recommendation. Because of all these cavities on here, I'm going to recommend using an oil that's more liquidy than more solid like a wax. As you move over all these edges, adding a finish that needs to be massaged into the wood like a wax, you could miss some. And then that little clump of wax you missed is going to harden, and then you'll have to clean that up later. Oil has more of a penetrating effect, so it'll soak into the wood, and there won't be anything to clean up later. Then I just stuck some of these adhesive back felt pads onto each corner to elevate it a little bit and hopefully mitigate some of the potential wood movement over time, allowing it to set flat on a table. That was a lot more than I thought it was going to be when I started working on this thing. But hey, nothing good comes easy. And now it's done. Worth it? I think it will be when I see the look on my parents' faces when they say, we don't even like Scrabble. That is why we make stuff. Anyway, I hope you found this helpful, and if you do decide to compromise the quality of your life by making one for yourself, we'd love to see it. As always, if you find any sort of value in these videos and you would like to help keep me employed, make sure to subscribe to the channel, like, comment, do all that YouTube stuff. Oh, and click that notification bell so you can see when we post new projects. And this one took a while, so the next few are going to be easy and fun. Alright, well that's all I have for you today. Thank you so much for sticking around and watching. Y'all be good.